Welcome to today's class, AS Math with Joy. So today we're going to be looking at sum and product of roots of quadratic equations. And I want to believe that you've seen the previous videos on quadratic equation by factorization method and completing the squares and all that. Alright, so please, if you're yet to subscribe to this channel to get notifications on our videos, please do like, comment, and share. Now, recall, because it's always good to start with previous knowledge, right? Good. Now, we said that a quadratic equation is an equation in this form: ax squared plus bx plus c, right, is equal to 0. Good. Now, quadratic equation will always give us two roots. We always have two roots of the equation, right? Why? Because we have the highest power of the unknown to be what? 2. But if you have polynomial in higher degrees like degree 3, that means you have how many roots? 3, right? You have 3 possible values for what? For x. All right. So now we say let the roots of this equation, let the roots of the equation. Now when we say roots, while solving a quadratic equation, that thing you say let at the end of the day, that result you get, x is equal to this or that. That is what we call the root. So let the root of the equation be alpha and beta. So if the roots are alpha and beta, what will the factors be? It means that the factors of the equation will be what? If the roots are positive, the factors will be negative, right? Now, what am I trying to do? I'm trying to form the equation whose roots are alpha and beta. All right. So if we open the brackets, so I just equated the factors to 0. The factors are x minus alpha, x minus beta. So equating to 0, why am I equating to 0? I want to get back the equation. So x times x will give me x squared. X times beta will give me plus minus, because there's a minus sign there, minus beta x, minus alpha times x will give me minus alpha x, and then minus times minus will give me what? Plus. Alpha times beta will give me alpha beta. This is equal to 0. Now, if you look at this middle term, you will see that they have something in common, and that includes their sign. So I'll bring out the sign and bring out what they have in common. So now whether I say alpha plus beta or I say beta plus alpha, it is the same. All right, just that it's always best to start with the first, just like when you say AB. It's just like asking, because I know that somebody will be wondering, why did you not write beta before alpha? Now note, A, B, B, A, it is still the same. But why is it always advised that we write A first? Because in alphabet, A comes first. That's just it. So whether it is A, B, or B, A is still the same. Now, this equation we have, let's call it equation 1. Now, let's write down the original equation we had, ax squared plus bx plus c is equal to 0. Now, can you compare equation 1 with this one I've written? You will discover that the coefficient of x squared here is a, while the coefficient of x squared here is 1. And we have said that the root of this equation is alpha plus beta. So they have to be the same. And how would they be the same? By dividing through by what? A. All right, so that the coefficient of x squared will be what? 1. Good. So if I divide through by a, I will have x squared plus bx over a, or b over ax is still the same, plus c over a. So 0 divided by anything will give us 0. So let's call this equation 2. Now compare 1 and 2. Compare 1 and 2. So if you compare equation 1 and 2, let's see if they are the same. Alright? So we see we have x squared here, we have x squared here. Let's compare the middle terms. Comparing the middle terms, we have minus, that's the coefficient of x anyway. So the coefficient of x squared is 1 already, so we don't need to stress ourselves. But the coefficient of x, we have minus alpha plus beta to be equal to what? B over A, right? Now, so what is alpha plus beta? Alpha plus beta is the sum of the root. Remember we said let the roots be what? Alpha plus beta. Good. So now we get rid of this minus by either by multiplying both sides by minus 1 or dividing through by minus 1, right? So when we do that, this minus will go. And why are we doing it? Why? We are looking for alpha plus beta. And what is alpha plus beta? The sum of the roots. So you know that the sign of the numerator is positive, right? So this becomes minus b over a. I know that somebody will also ask, but barrister of maths, the minus sign is in the denominator. Okay, let me answer you. Plus divided by minus is what? Minus. Alright, so when plus is divided by minus, that's why the minus is here. So this is the what? The sum of the root of the roots of the quadratic equation we had there. Now let's compare the constants. Comparing the constants, we will have alpha beta to be equal to c over a. So let me move up a bit so that you can see the constants. So look at what we have there. We have alpha plus beta. This is it. And this is the constant we have in equation 2. So if you compare both, you see that alpha plus beta is equal to c over a. As simple as that. And this is what? Product of the roots. So each time you have, why is it important you learn this? So when you have a question or a problem, whether you are a math or further math students preparing for WAEC, NECO, JAMB, GCE, blah, blah, blah. Now, whenever you have a question of quadratic equation involving sum and product, don't stress yourself trying to solve the equation completely to get the roots, then coming to add or to multiply. No. You simply use this, compare. Pick your alpha plus beta and pick your alpha times beta. Alright, so very quickly, we're going to pick a wire question and then use it to explain further. Alright, so at the end of that question, as usual, I will give you the one you will try out and give me feedback. Okay, now look at this example. Alpha and beta are the roots of the quadratic equation that. So we are to find alpha plus beta, that's the sum. Find alpha beta, which is the product. Then we have alpha squared plus beta squared and all that. All right. So let's roll. So what is the first thing to do? Now, the first thing to do is to write down your equation, which is 3x squared minus 4x plus 7 is equal to 0. Now, for the first one, which is alpha plus beta, that is sum of the roots. And we've said that sum of the roots is minus b over a from what we've done above. So now compare this equation, this is our quadratic equation, with ax squared plus bx plus c is equal to 0. So comparing from this our equation, our a is 3, Our B is what? -4. I think it's important we write down. A is 3, B is -4, and C is 7. So writing it out to make it easier for us to simply impute the numbers. Also be careful with the signs. All right, because if you don't write it out, someone who is in a hurry might write B as 4, not seeing the negative sign. Okay, so now substituting here, we've already gotten our B to be -4. So substituting, we'll have, we already have minus here, so we'll have -4/3. And when minus multiplies minus sign, you have 4/3. So our alpha plus beta is equal to 4/3, which is one whole number 1/3. So quickly we move to the next one, which is the product alpha beta. And we've said that alpha beta is C/A. So substituting, just like we did in A above, our C is what? Our C is 7. So C/A is 7/3, which is equal to 2 whole number 1/3. Now let's get into the main business of the day, because in external exams, most times nobody tells you find alpha plus beta or alpha beta. But whether you are told to find it or not, you will always need it. All right. Now, the question I lifted was actually WAEC question, but number A and B were not added. I just added it so that you can see how to get sum and product. All right. So in external exams, you are not asked to find alpha plus beta, alpha beta. So whether you are asked or not, just know that is a necessity, it's a requirement for you to find whatever you have to find, because you must definitely use, either you're using alpha plus beta or alpha beta. All right, so let's go to the C question. Let's quickly get to the C question. Now, the C question says find 1/alpha squared plus 1/beta squared. All right, now to solve this B, so please, I want you to take note of what we got here and here, because we'll be needing it at some point. So take note. See why I said whether you are asked to find alpha plus beta and alpha beta, you will sure need them. All right, because you can't evaluate further without those two. That's what you actually use. So first of all, you express as a single fraction. So to express as a single fraction, you take LCM, right? Good. Remember, we don't know alpha separately, we don't know beta separately, but we know alpha plus beta and we know alpha beta. So that's the essence of expressing as a single fraction. So if we do that, we'll have alpha squared beta squared, right? Okay. So now alpha squared divide alpha squared beta squared will give us beta squared plus beta squared divide the LCM, you'll have alpha squared. All right. So now let's start with the numerator. Let's start with the numerator. Remember, we know alpha plus beta. Let's see how that will help us find beta squared plus alpha squared. Now let's use the expansion beta plus alpha all squared. So if you open this expression, this is alpha plus beta. Let me just start with alpha. Remember, I said it's still the same whether you start with alpha or beta. So if you open up this, you have alpha times alpha, alpha times beta, beta times alpha, beta times beta. So if we add the two middle terms, which are like terms, you have alpha squared plus 2 alpha beta plus beta squared. and this is equal to what? Alpha plus beta all squared. Now remember that what we are looking for is this. So we have it here. So we're going to take this middle term to this side. All right, so that it will clear from our way. So when we do that, we'll have that alpha squared plus beta squared. When 2 alpha beta goes over to the other side, it will turn to negative, right? So we have minus 2 alpha beta. You see? So we've known how to get our numerator. You see why we need to get this and this, right? Now, why am I writing this? If you already know how to derive it, that alpha squared plus beta squared is alpha plus beta all squared minus 2 alpha beta, you only put it there and substitute. Now, for the denominator, alpha squared beta squared is the same as alpha beta all squared, since they are all squares, right? Good. So you see, so our fraction is going to be this beta squared plus alpha squared over alpha squared beta squared will be equal to alpha plus beta all squared minus 2 alpha beta all over what? Alpha beta squared. So what's our alpha plus beta? Remember I said you should write it down because we'll be needing it, right? So let's go back and check our alpha plus beta. So remember we got our alpha plus beta to be 4 over 3, while our alpha beta is 7 over 3. So let's substitute. So let me write it down here. We have 4 over 3. And then our alpha beta, we have what? 7 over 3. Okay. So moving forward, we would have 4 over 3 all squared. Put your bracket so that you don't end up squaring just 4. Minus 2 into 7 over 3. All over 7 over 3 all squared. So if I square 4, I have 16 over 9. Opening the bracket there, I have 14 over 3. Just know that it is only the numerator that 2 will multiply. This will multiply this will multiply this, right? Okay, so let me make it in a way that it will be easier for us to digest. So let me use divided by. If I square 7, I have 49. If I square 3, I have 9. Why did I put this in a bracket? If I don't put it in a bracket, you go ahead and apply BODMAS, right? You do division before subtraction. So putting it in a bracket, you will know that the numerator should be sorted out before bringing in the denominator. So when we take LCM, the LCM of 9 and 3 is what? Is 9. So that will give us 6. 3 into 9 is 3. 3 will multiply 14. And that should give us 42, right? Okay, divided by 49 over 9. All right, so 16 minus 42 would give us, okay, let's have 42 minus 16 by the corner. We have 6 here, 3 is left here. We have minus 26 over 9. So changing that division to multiplication, we have 9 over 49. So this 9 will take this 9. So we have minus 26 over 49. Is there anything that can we reduce this fraction further? I don't think there is a common term that can divide. As given that is a proper fraction, we leave our answer that way, right? Good. So I want to believe that anywhere you see quadratic equation involving sum and product of roots, please, I want to challenge you to give it a try. Okay, just try it out, and then if you have any challenge or whatsoever, you let me know. So could you please try this and give me feedback in the comment section? Okay, so I want you to try out this question for me and let me know your issues if you have any. All right. So now for this C, you may be wondering why you are seeing cube. So please do not bother. What you will simply do is when you are done with this, all right, it's just like saying when you have alpha plus beta squared, you expand, right? To get alpha squared plus beta squared plus what? Plus 2 alpha beta, right? And that was actually what we used for this. So in this case, what you will use will be alpha plus beta cube, all right? And that is just like saying alpha plus beta squared times alpha plus beta. So what you simply do is this one now, multiply it again by what? Alpha plus beta. Do you understand? And then you pick your alpha cube plus beta cube and then move every other thing to the other side. Is that clear? All right, so please try and give me feedback. Do well to like, share, comment, invite your friends. You really need to subscribe so that you will get notification on our videos. Thank you very much for joining us. See you in the next class. Bye.